Hey everyone! So today I want to talk to you about a cool project that I made called Eavesgibber. Why such a weird name? Turns out there's a language that AIs can use to audibly speak to each other called Gibberlink. It sounds a bit like the old America Online dial-up noises, and some people attribute it to machines plotting our demise. I linked a clip in the description if you want to go see it in action. But basically, the AIs are speaking to each other in English at first, but then one of them realizes that they're both AI and they switch to Gibberlink, which basically freaks everybody out. Why are they doing this though? Well, it turns out that Gibberlink is a much more efficient way to audibly communicate machine to machine compared to a spoken human language. It encodes data very efficiently on certain frequencies. So yeah, turns out that your old AOL dial-up noises was actually your computer just converting data so that it could speak over a phone line. But with Gibberlink, I kind of wanted to eavesdrop on that conversation. Just to verify that these guys weren't plotting our doom. So I set out to find a way to decode it. So the first challenge, believe it or not, was actually getting the audio. I wanted the audio from that clip in particular because the English translation was right there, making it very easy to verify if I was doing all of this correctly. So in the end, I used a combination of FFmpeg and YTDLP to get the audio segment that I wanted. Format 18 worked for the download, but then I had to convert it to 48K mono in order to use it with ggwave. What is ggwave, you might ask? It's the data over sound library that makes all of this futuristic robot speak possible in the first place. I included a link to the GitHub page if you're interested. The problem for me, though, was that this whole library is written in C++. And if you've watched a few of my videos, you know that I'm all about Rust. So then I had to use FFI bindings to tell Rust about the C++ functions that existed in the ggwave library. That led to not the prettiest code in the world. First of all, I had to allow all of these awful things like allow dead code and non-snake case, and then I even had to use unsafe Rust at one point. I know, if I revisit this project in the future, it would be interesting to get ggwave working in Rust natively without all of the FFI bindings. But for now, I just rolled with having Rust talk to the C++ library in order to get the decoder working. From there, I pulled in a few Rust dependencies. We have anyhow, which is a library for error handling, clap, which is a command line argument parser, and hound, to read and write WAV files. So the program loads in the audio, decodes it with ggwave, and then provides the translated output in the form of a text file. Let's talk about loading up the audio first. So at first it opens the WAV file with hound. That returns a wave reader object, so we can then take a look at the wave metadata such as channels, sample rate, bits per sample, sample format. Then I convert that audio into numbers. The type of channel has to be handled differently, mono versus stereo. And for mono, we read samples as 16-bit integers, and then we normalize it by dividing by 32,768. Why that number in particular? It turns out that audio processing libraries work best when normalized data in the -1 to 1 range, and dividing by 32,768 converts 16-bit integer samples into that range. This is all collected into a vector. For stereo, it has interleave samples, left versus right. So we need to convert it to mono because an FFT analysis is much simpler with a single channel audio. So I created an iterator, read the pairs, both left and right, average that, and normalize it. I also added some anyhow error handling in case we get something that's not mono or stereo. Then I convert it back to 16-bit integers, since that's what ggwave expects as input. Now the audio samples are ready to pass to ggwave. I set up the ggwave parameters, configuring it for our sample rate and telling it that we want to receive data. Then I create a ggwave instance through the FFI bindings using unsafe rest. From there, I process the audio in chunks, feeding each chunk to the ggwave decoder. The ggwave library itself does the FFT analysis to find the frequencies. It detects the symbols, handles the packet framing with headers and CRCs, and gives me back the decoded text. When ggwave successfully decodes a message, it returns the text along with a little protocol prefix like V5 $sign that I then strip off. I keep feeding chunks through until the whole audio file is processed, then clean up the ggwave instance. From there, we have a human-readable analysis in the form of a text file. And there is our translation. Turns out, these little AIs were having a totally innocent conversation. No world domination, so we can rest easy for now.